the continuation topic is nothing but the probability, which is an interesting topic and a most general topic. Everyone can learn this. Everyone can learn this because in the title itself you can see the probable. Probable means possibility. The possibility of the day-to-day events. What are the day-to-day events generally like? It may rain today, if I say. It may rain or it may not rain, we don't know. It's all expectations. India may win cricket against Pakistan, if I say. Then we don't know, it's a prediction. We don't know the exactness of that statement. So, in such a case, to give the mathematical shape to such type of statements which are passed vaguely, that is, which are passed casually. To give a mathematical shape, the mathematician tried to give a formula, or rather than a shape to such type of mathematical, such type of statements, a mathematical shape. It was, according to the books, it was given from 16th century, starting from Galileo, and till the end of 19th century. It has taken many steps, many changes, and many contributed to the theory of probability, including many Indian mathematicians, and it was given a shape. And in fact, we have, according to our Puranas and all these things, we have this probability right from Mahabharata. And you can see that if you take Shakuni, he used to play gambling with Dharmaraj, and you might be knowing that. So we have that history. India is very rich in mathematics. If you take, we know that theory, and later on this is given a shape mathematically, and let us see now how this can be defined. To begin with, we have the classical definition on probability. If you go to the definition, in a random experiment, if I say in a random experiment, then you might be thinking, what is a random experiment? What is an experiment and what is a random experiment? Let us see that. If there are n number of mutually exclusive, equally likely, exhaustive events, in the first sentence itself, you can find three technical terms. Number one, random experiment. Number two, mutually exclusive. Number three, equally likely. Number four, exhaustive. And all these four are used technically to define the probability, classical definition on probability. So we must know all those four terms before learning the definition. So let me first define you what is a random experiment. First of all, what is an experiment? Generally, for the purpose of definition, it is termed as the experiment. Experiment is nothing but every day-to-day work, what we take up. If you take all of them as experiments and what we conduct, what the works we do, or if they are termed as experiments, among those experiments, what should be the random experiment? That is the important thing here. So, you are throwing a coin, you are tossing a coin, you are throwing a die, you are playing cards, and you are appearing for an IIT-JEE examination, and you are appearing for all other examinations, even you are appearing for a board examinations, and all these are generally termed as experiment. You can take all of them as experiments. Then what should be the random experiment among all of them? A random experiment is that experiment which can be repeated any number of times, under similar conditions, and all the possible results or outcomes are known to us. All the possible results or outcomes are known to us when the experiment is conducted. And if you conduct that experiment once, then the result or outcome should be one of all the possible outcomes, should be one of all the known possible outcomes. Then only it is said to be a random experiment. For example, simple, I have taken a coin. If you take a coin, Indian rupee coin, you know, on one side you have tail, on another side you have head. Before tossing the coin, you know, the coin is containing head and tail. Before tossing the coin itself, you know that if the coin is tossed, then the outcome or result should be one of the tail or head. This is an important thing you have to understand. So, before conducting the experiment itself, you know all the possible outcomes. After you conduct the experiment, the result what you get should be one of all the known outcomes, should be one of all the known outcomes. For example, for the better example, I'll tell you, if you take Amitabh Bachchan and Dharmendra, a movie, Sholay, if you take that, and you might be remembering, Amitabh Bachchan has a coin which has both sides head. And he used to use that coin throughout the movie. At last, Dharmendra will be knowing that that coin is containing both sides head. So, but Dharmendra was under the impression that because he was under the impression that it's a random experiment. Because Dharmendra is under the impression that it contains both head and tail. But that coin is containing both sides head. Then, according to the assumption of Dharmendra, then it was a random experiment, but it is not a random experiment because the coin is not containing both tail and head. So understand like that. So if I prepare a die, generally you know about the die. Die is a 6-faced die. Then you know on each of the faces, 1 point, 2 points, 3 points, 4 points, 5 points, 6 points are marked. Then when we throw the die, either 1 or 2 or 3 or 4 or 5 or 6 comes, isn't it? So, if I prepare the die in such a way that the first phase is containing 1, second phase is containing 2, third phase is containing 3, and 4, 5, 6 phases are containing only 4. I know that. I know that because I prepared it. Like Shakunu has his own instruments to play in Mahabharata. You might be knowing that. So similarly, I know that this die has only 1, 2, 3, 4, but 5, 6 is missing. But I am playing with some other person and he is under the impression that this die is containing 6 phases with all the 6 digits, 1, 2, 3, 4, 5, 6. Then in such a case, according to him, it is containing 6 phases. But it is not a random experiment because he knows, he is under the impression that it has 1, 2, 3, 4, 5, 6, but it has no 5 and 6. Then it is not a random experiment. But it can be made as a random experiment if it is revealed to him. If it is revealed to him, we said with him like first phase 1, second phase 2, third phase 3, and remaining all the 3 phases are containing 4. Then it becomes a random experiment. It's fair like that. So, to be more precise and to be more clear, the random experiment is that experiment in which you know all the possible outcomes before conducting the experiment. That is, all the possible outcomes are known to us, and if you conduct the experiment, the outcome or result should be one of all the known possible outcomes. Then only it is said to be a random experiment. Next, coming to the mutually exclusive. What is a mutually exclusive event? You might have learned all this in your board level itself, but you must be more clear in the definition part, because in the questions you might be asked to, on the options you may be given this, mutually exclusive, equally likely, simple event, compound event, and all this you might be given. So you must know what all this. Mutually exclusive, the name itself, you have the meaning of a mutually exclusive. That means if I toss the coin, I have got head. There's no question of getting a tail, because occurrence of head is excluding the occurrence of tail. Understand it? So if I throw the die, I have got number 3. I got number 3. Then getting number 3 is excluding the happening of 1, 2, 4, 5, 6. Understand it? That is nothing but mutually exclusive events. What does it mean? No two events in the random experiment occur simultaneously. What does it mean? If I throw the coin, either head or tail comes, but both head and tail never come. That means the occurrence of one event must exclude the happening of the other event. That is why they are said to be mutually exclusive events. Simply, no two events in the random experiment occur simultaneously. That is, occurrence of one event excludes the happening of other events. Okay, that is mutually exclusive. Next, equally likely. In the definition itself, you have all these terms. That is why these are the technical terms you must understand. What are these? Equally likely events. Equally likely, like this, you have the meaning of this word itself will give you the definition. What is equally likely? Tossing a fair coin or unbiased coin. Or simply we can say fair coin. You might have come across this type of terms. What does it mean by unbiased coin? Fair coin. Fair coin means if you take the coin, the surface on the top must be equal to the surface area in the down. That means the surface area on both the sides must be equal. Then it is said to be an unbiased coin that should not have lesser surface area on any one of the sides. So when you toss a coin, equally likely events means the chance of getting head is equal to the chance of getting the tail. Then they are said to be equally likely events. Similarly, if the die is taken, fair die or unbiased die is taken, when you throw the die or when you toss the die, there should be equal chances of occurrence for 1 or 2 or 3 or 4 or 5 or 6. That is nothing but equally likely. You will be better understand if I define the die like this: first phase containing 1, second phase containing 2, third phase containing 3, and 4, 5, 6 phases are containing 4 each, and I defined that now. I defined the die is like this. Then in such a case, the getting 1 and getting 2, getting 3, getting 4 are not equally likely. Are equally likely because 4 is on 3 phases. There are more chances for 3 to occur when you conduct the experiment. So when you take a fair die or unbiased die, you understand the surface area of the die on 6 faces should be equal. If any surface is more or less, if it is more, the die will settle itself on that side more. If it is less, that will not come on that side. That will be a biased die. And what the example I have given also is a biased die. Unbiased die means there should not be any partiality towards any event to occur more rather than the other. Such events are said to be equally likely events. Okay, equally likely means there are equal chances of occurrence for every event to occur in a random experiment. For example, if you throw the die, how many even numbers are there? 2, 4, 6. How many odd numbers are there? 1, 3, 5. 3 even numbers, 3 odd numbers. 3 even numbers, 3 odd numbers. What does it mean? Getting an even number and getting an odd number in throwing an unbiased die are equally likely, because there are equal chances of getting either odd or even, then they are said to be equally likely events. Okay, now you must know this also, simple event and compound event. What is a simple event? Event is simple and it is compound. In the name itself, we have the meaning of it. Simple event means I have thrown a die. Then I ask, I need an odd number. Then if I need an odd number in throwing a die, I may get either 1 or 3 or 5. That means my wish is split into 3. My event is split into 3. What is it? 1 or 3 or 5. Then such an event is not a simple event, but it is a compound event. Such an event is not a simple event, but it is a compound event. If I ask number 3 in throwing a die, then it cannot further be split. Then in such a case, it is nothing but a simple event. It's nothing but a simple event. Understand? Simple event further cannot be split into 2 or more than 2 events, but compound event can further be split into 2 or more than 2 events. Such events are said to be simple event, means cannot split, and compound event means can be split. Like if you take 52 playing cards, then if I ask you a king, 4 kings are there. Diamond king, spade king, heart and king, and a clubs king. So 4 kings will be there. That means if I ask king, that king is split into 4 again. So that is nothing but a compound event. If I ask only for a diamond king is only 1, which cannot further be split, which is nothing but a simple event. Understand that? Now, after knowing all these things, very, very important thing and the basic thing which you must know in the probability is nothing but exhaustive events. Or sample space, or simply total number of outcomes. We can say this as the heart of probability, because if you don't know this, you don't know what is required. So it is very important to understand that you must know the total number of outcomes of any random experiment. So what are they? Let us discuss that in detail before going to the definition.